Pascal. We're going to resume our discussions this afternoon. We'll have keynotes and roundtables up until 5:30. We'll talk about decarbonization. We'll also look at compliance. And the closing will be very geopolitical. So without further ado, I'd like to give the floor to Laurent LEBLANC, who's a technical vice president with Bureau VERITAS Marine and Offshore. He'll talk about the changing environment of the maritime world. You have the floor. Thank you. I hope everyone can hear. Ladies and gentlemen, good afternoon. I hope you had a relaxing lunch and that you're all ears to listen to the discussions this afternoon. I won't be very long. I'd like to cover two aspects of things: the need to decarbonize in the maritime world and the presence of cyber threats and the way in which we can protect ourselves. Decarbonization will be divided into two parts: the challenge in general, and in particular for the maritime world. The second stage will consist in looking at new fuels, which will enable us to prepare for decarbonization. And in terms of the VERITAS classification, what are the classification standards we're preparing to ensure that construction, shipping is clean and safe? Let's start by talking about the need to decarbonize. This is a global challenge. We currently use around the world 600 exajoules. That's a huge amount. I think it's 10 to the power of 18, something like that. And in the various scenarios we have today, with a view to decarbonization by 2050, you can see that bit by bit, and in a relatively powerful way, the shares of fossil fuels, which are preponderant today, bit by bit are replaced by renewable energies, or energies which don't emit much CO2. On this graph on the right-hand side, with that green ellipse, you can see where there are no emissions or very low emissions, or we can absorb the emissions in the lower part. You can see in the future, according to these scenarios, the shares of fossil fuels, gas, oil, and coal. It's worth noting that transporting fossil fuel is mainly between continents and countries via shipping. It's shipping which is very active in this area. And the share of shipping of fossil fuels at present amounts to 35%. That's a lot. 35% of the world fleet is used to transport fossil fuels. That means that if by 2050 we are to do away with fossil fuels, or at least neutralize them, this will have an impact on the maritime industry. There may be different impacts. The impact can be constructive because we could replace a current oil or gas tanker by vessels that transport new forms of energies or fuels. But for a certain period of time, these vessels will reach the end of their lifespan. They won't be replaced because they won't be able to be reused in a different way. So the fleet will grow older on a market which is quite sensitive when it comes to the environment and safety. The current consumption of the maritime world is 10 to 11 hexajoules. We talked about 600, but it's 10 to 11 in terms of shipping. That's 300 to 330 million tons of different kinds of fuel. Not all kinds of fuel are equal. Some people talk about 200 or 300, but basically that's what we're talking about in terms of this kind of fuel. And each ton of oil or each ton of maritime fuel burnt generates 3 times more CO2, 3 times more in volume. We're talking about 300 or 330 million tons of fuel used by fleets. That turns into 1,000 million tons of CO2. If we had to have carbon sinks for all the CO2 produced by vessels, which burn 300 and 330 million tons of fuel, we need to have over a huge percentage of tankers which would transport the CO2 so it could go into a carbon sink. So this is not a mean thing. This kind of trend is fairly major when it comes to the energy needed. Look at the share of oil in brown. In gray, you have gas and diesel fuel. And you can see that the numbers are matching the growth in GDP. That's in red. So even if the scales aren't the same, the trends are pretty well matched. The demand for energy keeps pace with the growth in global GDP. We're talking about $85,000 billion in GDP, and it'll be 125 within the next 5 years. So you can imagine a similar demand for energy. 25% of GDP is represented by the US. France doesn't account for much, 2.6 out of 85, but it contributes, like all the industrialized countries, to the increase in demand. Now, what's the breakdown of CO2 in industrial sectors and in the maritime sector? Transport in general, look at the pie chart on the left. Transport is in light blue, 24 to 25%. And these figures were probably mentioned this morning. Everything depends on whether you take account of CO2 created by farming, which is not on the graph. That would add 20 out of 100, but the contributions would be the same. Between 15 and 25% of CO2 emissions come from transport, whether you take into account the CO2 produced by farming or not. And now let's look at the maritime sector within this 24%. On the left-hand side, it's 11% in light blue on the right-hand side pie chart. 11% of 24% according to this estimate. That's 2 to 3% of CO2 emissions that basically come from shipping, and a little bit less if you include CO2 emissions based on farming. So we're talking about 1 billion tons in emissions. That's about 3% of global emissions, 11% of transport. One should realize, however, that 85 to 90% of goods exchanged in the world are shipped by sea. So shipping, in many respects, is a key form of transport for these huge volumes of merchandise. It's also worth noting that these vessels currently used, there are about 100,000 vessels plying the seas, and inland waterways, 20% of the international fleet. 20% of the fleet creates 85% of CO2 emissions in the maritime sector, mainly CO2, as you can see on this graph on the right-hand side. You can see CO2 emissions, and that's that big blue mass here. And then you have some narrow lines in the upper segment that represent methane, which is hardly visible. It's in green. And nitrous oxides, laughing gas, N2O, laughing gas is 25 times more powerful when it comes to creating greenhouse gases. In the current situation, when it comes to the motors and the fuel of vessels, N2O is still fairly marginal, but it may grow in importance, as we'll see a bit later on. Now, what about trends? What about the growth of decarbonization in the maritime sector? This right-hand slide or graph shows you the situation in 1990. Here you have aviation, shipping, and global trends starting at 1 in 1990. Look at the trends. Growth is 1.5 times the emissions in 1990. Aviation 2.5 times greater, and maritime shipping times 2. In 2018, as you see here, there's an increase of 2 compared with 1990. Compared with 2008, levels have remained almost equal or even lower than the value initially plotted. Look at this green line here. That's the level of emissions in 2008 and what these emissions are now. It's almost the same, whereas you have 2 more times vessels, 2 million tons. The value was 1,000 in 2008. So things have doubled since 1990. Some part has remained fairly stable since 2008, and between 2008 and 2018, you can see there's a huge increase in the volume produced by vessels, yet there hasn't been a huge increase in emissions. Now, what about projections? Various entities have created future scenarios. On the lower part of the graph, you have the goal of 0 CO2 by 2050. In the upper section, you have other scenarios. In both cases, these scenarios comprise socioeconomic scenarios as well. With each scenario referring to emissions, you have a socioeconomic scenario. And the upper part here, this was prepared by the oil industry, and you can see the upper part is totally different from the lower part, which was prepared by the International Energy Entity and the International Renewable Energy Organization as well. The share which evolves the most by 2050, it concerns hydrogen mainly and other plant-based fuels. And you can see what the status of the maritime industry is when it comes to fossil fuels. Those companies have proposed other scenarios where shipping isn't expected to use different fuels from those used today. New fuels are set aside for different kinds of activities mainly. Now, what about forecasts by the International Maritime Organization? If nothing is done according to their projections, there will be not an increase, but there will be 150% more CO2 emissions by 2050, given trends in shipping and the number of vessels according to certain scenarios. One can reduce greenhouse gas effects and CO2 emissions. The declared aim of IMO is a 50% reduction compared with 2020 when it comes to global greenhouse gas emissions, and up to 70% for CO2. In this context, shipping is turning to the quest for new fuels. Some of these new fuels already exist. There are 3 different categories. You have alternative fuels, mainly e-fuels. The 2 first mentioned here don't emit any CO2 during burning. The other 3 are fuels which, providing it's a virtuous synthesis production method, these fuels will create neutral emissions when it comes to actually making the fuel, burning it, and recovering it, recovering the CO2 in a virtuous circle. So these fuels wouldn't make more CO2. And then you have biofuels, including biomethanol. Other kinds of facilities are already being used in certain circumstances. For example, you have carbon capture systems on certain vessels, but not many. You can use sails to propel the boat. That is also developing. It's not like just a sailboat, though, because we're talking about huge vessels with which weigh 100 to 300 tons. Wind energy can contribute 15 to 20% of overall, depending on the route and exposure to wind, of course. And then you have fuel cells, which already exist. That's one possible solution for small vessels over small distances. Likewise, batteries, which currently make it possible to propel fairly small vessels. Now let's look at the other kinds of fuels, if they can be developed and actually used. You can see there's a big difference in CO2 emissions comparing what exists today. That is traditional fuels. VLSFO is a low sulfur fuel that appears in green. And then you have the biofuels, biomethane, biomethanol. That's the yellow part of this graph. The reduction will be threefold in CO2. And as to e-fuels, providing they're made according to a virtuous cycle, capturing the CO2 emitted, if CO2 is emitted at all, and then you use the CO2 again, or you can store it there. There would be a difference to the factor of 7 compared with current fuels. Then there's a thorny question, the cost of these new energies. Look at this graph, block by block. On the left-hand side, you have the current fuels, the most widely used ones. In black, you have market prices. In green and orange, you have production costs with different ranges. In dark orange, you have first-generation biofuels. You can see the minimum price per ton. The oblique bit is the market price, which fluctuates. Then you have the same thing for hydrogen in the second block. It can't be compared with fossil fuels. Ammonia can be viewed as a fossil fuel if it's burnt and made using fossil energy, or on the contrary, it can be viewed as a greener fuel if it's made synthetically and no CO2 is produced. Here again, you have a difference between minimum and maximum prices. There's a broad price range which goes far beyond what you can see for the time being with fossil fuels. So in this context, what is Veritas doing? What do similar firms do? We're preparing what we call different classes of fuels. This helps us to classify and certify vessels and their equipment. And we already have a certain number of markings, and that makes it possible for vessels either to be designed to burn these new kinds of fuels, or they can be converted where possible. What does that mean? That means that they have engines which can accommodate these new fuels, or the supply chains of for these new fuels in ports will become available. We're working on ammonia. We're studying this currently, and here you have a technical fact sheet. All these fact sheets are similar. There's a technical part. In the case of ammonia, you have a given volume for the same energy, which is 3 times greater than fuel. There's no engine currently for boats that burn ammonia. These motors, there are 2-stroke engines that use a liquid ammonia and 4-stroke with gas ammonia. You have the safety issue linked to these new fuels, particularly in the case of ammonia, which is highly toxic. A few liters of ammonia which leak into the machine room would be enough to create major damage for the crew. It's corrosive for the environment. Of course, there's very little greenhouse gas effect. There are hardly any emissions of CO2, or none during burning. However, you have nitrous oxide and N2O, which are byproducts, and they need to be taken into consideration if this kind of engine becomes widely used. The regulations have not yet been designed to accommodate these new fuels, and certainly for carriers of ammonia, unlike gas carriers. For example, you'd have to have dedicated holds or hatches for this kind of fuel. Now, when it comes to the classifications, we're very active in this area. With ammonia, we have issued our first regulations 1.5 years ago, and we shall be publishing this month by the end of June. We update our regulations every year in July, and we will be updating all these rules on these new fuels. Now, basically, what we're talking about is the areas, dedicated areas for storing fuel, the resistance of the hull in light of this kind of fuel on board, the stability of the vessel, given the type of fuel used and its density. And then there are some optional parameters which you can see here. Access to the spaces concerned, ventilation, structural provisions, have at least a special storage area, the original equipment for handling these fuels, and then we have the problem of the motors, which don't yet exist. Then there's a second kind of a fuel. I'm just trying to tell you that time is running out. I'll try and go quickly. I won't repeat things, says the speaker. You have a second fact sheet for methanol here. There are certain technical advantages, yet there are safety issues which are different. In any event, we have the first point, which is as follows. The volume required is greater than current fuels. You have certain dangers in terms of flammability. Carbon emissions could be neutralized thanks to storage or capture. And here again, the engines, the motors are not yet ready. The same thing applies to hydrogen. Hydrogen is being developed similar to methanol. The regulations are not quite ready yet. And we, as a classification company, share the work underway with various partners. The aim is to find viable solutions when it comes to using these new fuels. All these fact sheets are actually identical. Here you have the timeline. Things are speeding up. Yet, for the time being today, things are not clear or totally reliable. Here you have a summary of the situation when it comes to biofuels, and that closes the chapter on fuels. We'll have a big roundtable on cybersecurity, so I'd like to ask you just one last question. You'd place your bets on what kind of fuel? I wouldn't place my bets on any fuel because we just check on things. Our mission is to support industry, and in so doing, our role, of course, is to ensure that the solutions chosen are both reliable from an environmental stance and in terms of safety. There's a lot at stake. One has to be quite pragmatic when it comes to the use of gas, for example. Gas is a fuel that can be used instead of oil. A lot of engines can run on either gas or oil. Gas doesn't lead to a major drop in CO2. It's 10 to 20% compared with oil. And then you have biofuels, be they synthetic or natural. They should be able to be used increasingly. Methanol, in terms of engines, their technological progress is greater than biofuels like hydrogen and ammonia. For hydrogen and ammonia, things will have to evolve until the situation becomes really mature. Hydrogen is used in fuel cells currently, but on small vehicles or not on large vessels. Sorry, I've had to rush you on. I think for cybersecurity, there are much greater experts than I who will be able to address the issue more competently.